Okay, everybody, what is going on? This video, we're going to look at tangents and normals. We're going to learn how to find the equation of a line tangent to a curve and normal to a curve at a particular point. All right, so let's look and see how we do each one of them, and then I'll do a quick little sketch to show you what we're actually finding so you can get an idea of what's going on. So it says to find the equation of a line tangent to a curve, you find the derivative of the curve, evaluate the derivative at the point. This gives us the slope of the tangent line, and then use the point slope form from algebra. Y minus y1 equals m times x minus x1. And then to find the equation of a line normal to a curve, we find the derivative, evaluate the derivative at the point. This gives us the slope of the tangent line. Well, the slope of the normal line is the negative reciprocal of the slope of the tangent line, and then we use the point slope form. All right. So basically what we're finding here is, let me show you. So let's just say you have a graph here. We'll just draw a parabola. And you have a point here. That's the line that's tangent to that curve at this particular point right here. This is your tangent line, and that's the equation of the line that we're trying to find. Now for the normal line, well, let's just go up here. The normal line, you have a line that is perpendicular to the tangent line at that point. This is your normal line right here. All right, and you see that you have the tangent line and the normal line. They're perpendicular. Well, what do we know about perpendicular lines? Their slopes are negative reciprocals of each other. Okay, and that's why when you're looking for the equation of the tangent line, well, you evaluate the derivative. That gives the slope of the tangent line, and so the slope of the normal line would be the negative reciprocal of that. All right. All right, so let's get started on some examples. We've got, I think, 4 examples to work, 2 for the tangent line, 2 for the normal line, and then we have a word problem. So hang around for the whole video, you'll learn some stuff. All right, so find the equation of the tangent line to the parabola y equals x squared minus 1 at the point negative 2, 3. All right, so what does it say? Let's write the problem down. So it says find the derivative. All right, well, what's the derivative? Y prime is 2x. Okay, there's the derivative of x squared minus 1. And then we evaluate the derivative at the point. So the slope is y prime of, now I'm evaluating it at the point, but notice, see, I only have an x variable, so all I need is the x coordinate. I just need to plug in the negative 2, and so that's going to be 2 times negative 2, which is negative 4. That's the slope of the tangent line. Okay, and then we use y minus y1 equals m times x minus x1, and we plug everything in. So look at this. You know, I'm trying to erase that white line and it wasn't letting me. So we know that's m. This is your x1 and this is your y1. So we plug them in. So y minus 3 equals negative 4 times x, and then minus a negative 2 is going to be plus 2. And then go ahead and solve it for y. So y minus 3 equals negative 4x minus 8. So y equals negative 4x minus 5. And there's the equation of the tangent line. All right, So now let's see what we found. Okay, so I've graphed them. All right, so that's what it looks like. The green, that's the graph, x squared minus 1, and then the blue line, that's your tangent line. That's the line y equals negative 4x minus 5, and this is your point negative 2, 3. And that's what we found, the equation of this blue line right here. Y equals negative 4x minus 5. All right, let's look at the next example. All right, so find the equation of the line tangent to the ellipse 4x squared plus 9y squared equals 40 at the point 1, 2. All right. So 4x squared plus 9y squared equals 40. So we have to find the derivative. So we should remember how to do this, implicit differentiation. So that's 8x plus 18y times y prime equals 0. All right. And then we solve for y prime. So 18y, y prime equals negative 8x. Divide everything by 18y. And so we get y prime is equal to negative 4x over 9y. All right, so there's your derivative. So now what do? Well, we evaluate the derivative at the point. Now this time, notice how we have an x and a y. Okay, so we've got to plug the 1 in for x, the 2 in for y. And so that's going to be y prime of 1, 2, and that is going to be negative 4 times 1 over 9 times 2. Right. And so that's going to be negative 2 over 9. And let me go ahead and note this is m equals. That's your slope, negative 2/9. All right. Now we use y minus y1 equals m times x minus x1. So we've got, remember, this is x1, this is y1, and that's m, your slope. And so y minus 2 equals negative 2/9 times x minus 1. Y minus 2 equals negative 2/9 x plus 2/9. And so now I'm going to add 2 to both sides. So y equals negative 2/9 x plus, what is that? Is that 20 over 9? And so there's the equation of your line. All right. Now let's see what this looks like. And there's what that graph looks like. And here's your tangent line, y equals negative 2/9 x plus 20 over 9. And this is the equation of your ellipse, 4x squared plus 9y squared equals 40. All right. All right, so let's move on to the next one. So that's finding the equation of the tangent line. All right, so now let's look at some problems where we find the equation of the normal line. So it says find the equation of the line normal to the hyperbola y equals 2x at the point 2, 1. All right. So let's find the derivative. So we've got y equals 2 over x. All right. Now, let's go ahead and find this derivative. And one thing that I would recommend you do is y equals some number over x. It seems like this comes up, well, not all the time, but it comes up quite a bit in calculus where you have a number over x. And you can take this derivative by rewriting it as 2 times x to the negative 1 and using the power rule. So y prime would be negative 2x to the negative 2. So y prime is negative 2 over x squared. So what I've done is when I see a number over x, I just know it's negative that number over x squared. So see, if you have, let's say you have y equals c over x, some constant over x. So you get y equals c times x to the negative 1. So y prime is negative cx to the negative 2. So y prime is negative c over x squared. What I've done is I've just memorized it. So if you have a constant over x to the first power, just memorize it's negative that constant over x squared. Okay, it'll save you from having to rewrite it like this, do this step, and then rewrite it with the exponent positive. Okay, if you want to do that, that's fine. If not, that's fine. Okay, your teacher may not want you to memorize it. Your teacher may want you to write all this out. You're in my class, you can go from here to here. That's fine. And as often as it comes up, you'll probably end up memorizing it anyway. All right, so let's do y prime of, okay, so we've got to evaluate the derivative at that point. So I just need to plug the 2 in because all I have is an x value. So that's y of 2 is equal to negative 2 over 2 squared, which is negative 1/2. All right. So we get y prime of 2 is negative 1/2. That's not the slope of our line, is it? No, because they're wanting us to find the line normal to the curve. So that means our slope is the negative reciprocal of this. So what's the negative reciprocal? Well, you flip it and change the sign. All right, so there's your slope. There's m, there's x1, there's y1. So y minus y1 equals m times x minus x1. So plug it in, y minus 1 equals 2 times x minus 2. So y minus 1 equals 2x minus 4. Y equals 2x minus 3. And there is the equation of your line. And once again, how about we look at a picture of it? See, make it a little bigger. And there it is. And see, look, if you drew in, see, you could draw in the tangent line right here. See, if we kind of sketch that in, there's your tangent line. The blue line is your normal line. This right here is the graph y equals, what was it, 2x minus 3? Yeah. And then the green line is your y equals 2 over x. But yeah, this is this blue line, that's your normal line. And see, it's perpendicular to the tangent line right here. All right. All right, let's look at another one. We got this one, and then we have a word problem to do. And I hope you're still, well, I mean, if you're watching the video, you are, but watch this problem, okay? Don't get bored and just click the video off. Because look at this, they only give us x equal 3. You see that? All right. So find the y-intercept of the line normal to the graph of y equals 2x minus 1/3 x cubed, where x equals 3. So They're not asking us to find the normal line, they're asking us to find the y-intercept of the normal line. But to do that, we have to find the equation of the normal line. And so we have y equals 2x minus 1/3 x cubed. There's our curve. Now, find the normal line to this graph. Now, what has it been telling us in the other problems? In the other problems, it's been saying find the line normal to the graph or tangent to the graph at this point. They don't say at this point. They say where x equals 3. Well, in order to find the equation of a line, we've got to have a point on the line, don't we? We need to know the slope, and we need to know a point on the line. Well, they tell us that x equals 3. So if x equals 3, so I've got the x coordinate of my point. So what's the y coordinate? Well, how do we find the y coordinate? Well, you take this and you just plug it back in to the original function to get your y, right? If x is 3, we plug it in here for x, and that'll give us y. And so I've got y equals, let's do this, y of 3 is equal to 2 times 3 minus 1/3 times 3 cubed. So that's going to be 6 minus 9, which is negative 3. So now, look, you can read the problem now. Find the y-intercept of the line normal to the graph of y equals 2x minus 1/3 x cubed at the point 3, negative 3. So sometimes they may just give you the x coordinate. Well, if they do, just plug it back into the function to get your y coordinate. All right, so let's take the derivative. So y prime is 2 minus x squared. And so y prime of 3 is 2 minus 3 squared. What is that? Is that negative 7? Okay. So the slope is what? 1/7. Because we're finding the normal line. So the slope is the negative reciprocal. All right. So I've got y minus y1 equals m times x minus x1. And so y minus a negative 3 is plus 3 equals 1/7 times x minus 3. So y plus 3 equals 1/7 x minus 3/7. And then I'm going to subtract 3. So y equals 1/7 x minus, and that's going to be 24/7. And what were they wanting us to find? They were wanting us to find the y-intercept. So the y-intercept is the point 0. Remember, if you have y equals mx plus b, m is your slope, and the y-intercept is the point 0b, whatever that constant is. So that's 0, negative 24/7. So that's what they were wanting us to find. But we did have to find the equation of the normal line. And so let's see what that looks like. So that's this right here. And so here's your curve. Y equals 2x minus 1/3 x cubed. Here's your line that's normal to that point. Okay. See, if we wanted to, we could, if we, well, that's not a very good drawing, but there's your tangent line. And yeah, that doesn't look good at all. Here's your normal line. It's perpendicular to the tangent line. And that's what we found right there. We found the y-intercept. Okay. All right. So we've got our last problem. This is it's a word problem. So let's look. The cross section of a parabolic solar reflector is shown in the figure below, along with an incident ray of light and the reflected light. The angle of incidence I is equal to the angle of reflection, R, where both angles are measured with respect to the normal to the surface. If the incident ray strikes at the point where the slope of the normal is -1 and the equation of the parabola is 4y equals x squared, what is the equation of the normal line? Okay, so that's a lot there, but let's see what we have to find. So we have our parabola right here. We have the normal line right here. It's that dotted green line. Let's just kind of put that in red. That's your normal line. Okay, and the slope of this normal line is -1. Well, they want us to find the equation. Okay, they want us to find the equation of the normal line. So what do we need? Well, we got the slope, but look, we need the coordinates of that point, don't we? And basically what's happened here, see, light's coming in and then it's reflecting off. Okay. All right. So how in the world are we going to find the slope or the equation, this line? Well, how are we going to find those point coordinates? Well, let's look at this. Slope of normal line is equal to -1. So that tells us the slope of the tangent line is the negative reciprocal of that. So I flip it and change the sign. So this is -1/1, so that'd be 1/-1, but change the sign, so that would be a positive. So the slope of the tangent line is 1. All right. So how does that help us? Well, look at this. 4y equals x squared. So if I take the derivative of this, let's take the derivative. That's 4y prime, implicit differentiation. Derivative of 4y is 4 times y prime equals 2x. So y prime is 1/2 x. You see that? So what this means is I'm plugging some number in for x and getting 1 as an answer, right? That's the slope of the tangent line. So I need to know if 1/2 is equal, 1/2 x is equal to 1, 1/2 x is equal to my slope. What x value is that? Well, I mean, obviously that's 2. We can see that. So x equals, see, if I multiply everything by 2, I get x equal 2. So look at that. That's the x coordinate. You see that? That's the x coordinate of that point. Well, what do I need now? Now I need the y coordinate. So if I take 4y equals x squared and I replace the x with 2, that's 4y equals 2 squared. So 4y equals 4, y equals 1. So that's the y coordinate of that point. And so can I find the equation of the normal line? Well, sure I can. I've got the slope. I've got my point. And so I'm going to use y minus y1 equals m times x minus x1. And so y minus 1 equals -1 times x minus 2. And so this is going to be y minus 1 is -x plus 2. So y equals -x plus 3. And that is the equation of your normal line. All right, so, for some reason, students make this difficult, and it's not. It seems like students, a lot of times, they get if you ask them to find the equation of the tangent line, they typically get that one right. But it's funny when you change it from tangent and ask them to find the normal line, it's just all of a sudden they don't know how to do it, which that shouldn't be the case, because both of them are worked exactly the same. It's just the slopes are different. Okay, just remember, when you plug the point into the derivative, that gives you the slope of the tangent line. You got your slope, you got your point. It's back to algebra. Okay? If they ask you to find the normal line, you're still evaluating the first derivative at the point. It's just your slope is the negative reciprocal of what you get. And then you've got the slope, you've got the point, and once again, it's back to algebra. That's all it is to it. Okay? So I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching. I'll see you in the next one. Later.